Hello everyone and welcome to a new episode of Svelte plus D3 doing data visualization with Svelte and D3. And yeah, today we want to build some Voronoi diagrams, and yeah, maybe you've seen something like this before. This is just an Instagram post that I saw from Now We'll Get today, where he is exploring a Voronoi diagram and moving one of the dots around and seeing what's happening to the diagram. And actually, this is not just very playful, this is also very useful when you build like click interactivity for scatter plots where dots are very close to each other and you want to expand the surface where you can click on it and touch on it, for example. Then you could use a Voronoi diagram under the hood. And of course, this is something which is already implemented in D3. So we do not have to think about the whole math around it. What you have to know is basically a Voronoi diagram works like this, that you have these dots. This is like these little black dots here. And then in the diagram, you mark areas that are closest, or where the points within that area are closest to the point, the black point here, that I just marked with my mouse pointer now. So like this point where my mouse is now is closest to that one. That's because we are in this area which is around this dot, and so on and so on. So this is a very nice geometrical thing, and yeah, we can build that very easily. And let's see if we can succeed to build this in under 20 or 30 minutes. So let's see. And of course we use Svelte together with D3. Here D3, we're using D3 just as a function library. So let's dive right into our code editor. And I've already set up my Svelte D3 starter project. Link to that is in the description, so you can find it very easily and fork it, clone it, whatever, and then work with it. And I've already spun up here my development server, where you see basically nothing, because in our app.svelte is basically nothing. So what we want to do now first is we want to generate some dots that are randomly positioned throughout my screen. So I would say let's start here in the JavaScript part and just put in some data, and we build a new array, and we say we want 100 dots. So array from length 100 creates an empty array with 100 entries, and then we iterate over these 100 entries, and we return an object for every entry where we say, okay, there is a coordinate A that is math.random, so some random number between 0 and 1, and we have a coordinate B which is also math.random. And that creates us some data, and we can also look into the data by just console logging it. So you can see it here. We have 100 entries, and we have A's and B's with a lot of random values. Now that was quite quick. It's just JavaScript here and there, and now we want to scatter these points around on our whole viewport. And for that I have this outer main element that I always use, and we say in the style that main should be should have a width of 100 view width, so 100% of our viewport, and the height is equally 100% of our view height. So that means if I go to the HTML, you can see our main element now spans throughout the whole space that we have in our browser window. Well, then we build an SVG inside, because we want to draw these dots on an SVG, and of course the SVG needs to have a width and a height. We don't know this width and height yet, but if you watched my previous videos, also there a link in the description, we have this pattern that we can grab the width and height from this main element, which is styled by CSS to have a certain width and height, which is responsive to the browser window viewport. And we can grab that, and for that we have to generate two variables, one for the width and one for the height. Let's write it like that. And then we could say, okay, let's use this width and height here. And of course, these variables are just undefined right now. But here in main with the bind directive from Svelte, and by asking what the client width is, we could just couple this with JavaScript variable to the HTML attribute client width that holds the width of this HTML element. And we do just the same for the client height and couple that to height. So now we should get an SVG within, yeah, there it is. And that's it. And sometimes you get these scroll bars, and I got a comment like in one of the previous videos, and it's totally right. It's a very good idea to say here for the main that there is no overflow allowed, so overflow hidden, so that you don't get like a feedback loop where you apply a certain height to your SVG, then the height here on the container changes again and again. So we just decouple that relationship by overflow hidden, and then you also get rid of these scroll bars. Well, then of course, that's also something we learned in my circles video earlier in this D3 Svelte season, D3 Svelte videos. We have to translate these A's and B's to X and Y coordinates that respond to different widths and heights that I might have. And for that we need something like an X scale, which is a function. And here we need scale linear. This is something we import from D3. Import scale linear from D3. And scale linear returns a function that we can adapt, and we can put on here a domain, which is some array between 0 and 1, and we put that to a range which is between 0 and width. That means X scale is a function that we get that translates our random A, B values that are between 0 and 1 to pixel values between 0 and the width, just a scaling function. And we use the $sign here because we want to regenerate that scaling function whenever the width changes. And I just copy that now, and we're doing the exact same thing for our Y scale. Here also we translate a value from 0 to 1 into a range, but not going from 0 to width, but now from 0 to height. Yeah, and then I would say we do a new array of data, which we call now rendered data. And this is taking just the data, and we map the data, and we return new objects that do not hold A and B now, but that have X. And here we use the X scale, put in the value of A, and we could generate a new Y, use the Y scale, and use the value of B. So now if we console log the rendered data, let's do that. Should be the last one here. So let's see. No, that's not. So let's just rerun it, and then it says it's undefined yet. So this is really interesting. Let's see what we've done now. We've got the data. We've got the width and the height. So what's going on here? So let's just look into the data again. So the data is an array with A and B. And now rendered data should definitely not be undefined actually. So this is really interesting. So best thing you could do, we could just console log D here to see what we're going to see, and there we have the A and B values. That looks nice. So if I would log D.A, we get all these values. So it seems that something is basically wrong with our X scale and Y scale function, because when I use an X scale here, well, we get pixel values that's looking really nice. And if we use that one here, we're getting all the y values. That's also pretty nice. So what's going on here? Well, this is really silly because it has nothing to do with that one. We just have no $sign here. So console log, this is quite interesting. Console log is just running once when the component is initialized and their render data is not set yet. That's why we get undefined. So let me just reload that. We get undefined because there is no render data yet. We do not have the XY scales. We do not have the width, height. So it is undefined. But if we use the $sign here, we get then the result as soon as width and height is there, and then we get our X and Y positioned arrays. So that's really nice learning. And now what we can do, of course, we could use our each block, loop over render data as D. That's in Svelte each block. And then we draw circles and, oops, that's one not so. And our Cx is D.x, our Cy is D.y. Let's take a radius of 3 pixels for now, and let's say we use a fill of, what should we take? Purple, and we use no stroke. And then, yeah, you can see now the circles here, and you can also see that they scatter evenly also when I change now the whole width. I could also change the height, of course. All right, that's looking good. And now we want to build a Voronoi diagram. So we want to see like these lines that are separating the dots in an optimal way. And for that, we need 2 functions from D3. So there is first a Delaunay function, capital D here. And well, let's say if we have a width and a height, then we could calculate Delaunay stuff. So Delaunay is, and I think this is something I don't use very often, there is Delaunay dot from, and then we could basically put in, if I am correct, the render data here. And then as the second and third argument, we could tell Delaunay where to pull out the X and Y values. So we have to put in here some excessive functions. So we say, well, the X value is in the X property of our object. And similarly, we have a Y accessor, which is looking like that. And now best we could do is just rerun, no errors. Okay, that's good. It seems to work. We have no idea what Delaunay is. So that's basically now a little helper variable, and then we could generate the Voronoi diagram from here, and this is using the Delaunay basically, and there is a function which is just called Voronoi, and this function here, the Voronoi function, takes basically an array which has the dimensions of the bounding box where we want to build now our Voronoi diagram, and we want to build it from 0, 0 at the top left, which is like that, until the width and the height that we have. So you see that we have here now the dependency of width and the height, and that's giving our Voronoi. And if we console log that Voronoi, we see, well, there is now a Voronoi object which has like a lot of interesting stuff, like these circumcenters, vectors, and also like dimensions and stuff like that. And it also comes with a lot of methods, and now we could make use of that basically. So what we could do is just, we do this Voronoi not as a constant variable, which is only known within that reactive block, but we make Voronoi basically a global variable. And then we could say, well, here we loop first through this array only if we have a Voronoi object. So if there is Voronoi, let's see if that's working out. Yeah, if Voronoi, and then we could also do like for each render data, we could also say, well, let's draw also like the cells. And here we could use an SVG path, and an SVG path takes a D attribute. And here we could say, well, there is Voronoi dot render cell. And this render cell here takes basically a number. So like for the nth data point, we need here the number I so that we get the cell. Well, we already loop over it, and we can get this index of our render data array by just doing this comma i's, and this is giving us the index of an array, and then we get like these paths of the Voronoi cells here, and we could just say, well, let's not use a fill yet, but let's use a stroke, which is steel glue, and here's our Voronoi diagram. So basically what's happening there, and it's really cool because now it's already responsive. So basically what's happening here is we use this Voronoi object and we call the render cell method for every point that we have in the data set. So I is running from 0 to 99. So for every 100 cells that we have, we run that and then we draw it. I could show you now a little bit that this is really working out. So we could here in the field, we could say, hey, if I is 0, so if this is the first cell, then make the fill also steel blue. Otherwise, don't use a fill. And if I do that, you can see, well, this here is our 0 cell. I could also do like something like that. So if I is smaller than, let's say 20, we see like the first 20 cells in our data set. So yeah, this is really nice. So we have access to these cells individually. All right, but let's keep that as let's keep that as with fill none for now, so that we can see the circles as well. But maybe let's adjust the stroke width a little bit, make that 3, so then it's a little bit clearer. So if you remember the video here, he moves this circle around and he changes one of the circles within the data set by moving this around. And I mean, we could mimic that, of course, by just using now our mouse position and resetting one of the circles, maybe just the first one in the data set all the time. And we can do that by just putting an event handler here on main, and there's, with this on directive from Svelte, we could access the mouse move event, and we could just call a function. Let's call it handle mouse move. Yeah, very innovative. So this function is called when there is a mouse move event. So we have to define this function. Let's do it here. Function handle mouse move, and this is getting an event as a parameter, and then from this event we can pull out layer X and layer Y. So this is now the mouse X and mouse Y position that we get back. And then we could say, well, we have the render data, and now we rewrite the render data, which is an array. And as the first element, we modify this now. So let me put it like that. So we set in a new X, which is our layer X. And we set in a new Y, which is our layer Y. And all the other 99 elements, we keep it the same. So we fill in here all the render data dot slice 1. So this is all the rendered data, but not the first element. That's basically it. Let's see what's happening now. So you can already see when I move now my mouse over it, yeah, it's really changing this one circle. Probably we can make that a little bit clearer visually. So maybe we say that the radius of the first element, let's make this a little bit bigger, let's make it 10 and otherwise 3. And then yeah, you can see the circle that we're moving around a little bit better. 10 is probably quite exaggerating, let's use 7. And of course we could also color like this whole cell a little bit differently. So we could say, well, let's access here the fill properties. So if we are at the 0 thing, then we put in a fill here. So which colors do we have? We have pink, which is quite nice, and otherwise we do not alpha but none. So now you can see, okay, this is our cell that we are moving around. But there, well, now you can see that we do not see the circle anymore, as there is a fill in this cell, and this is just a thing how SVG works. So things that are drawn lastly are over everything else. So we just have to draw the circles. So I'm cutting them out after we've drawn the path, and then yeah, we see the circle again. Wow! And this is now our final program. We build a Voronoi diagram with a moving circle on mouse move event. Cool. Wow. That's it. Thanks for watching, and see you next time. Bye.